Hi everyone. So the goal of this video is to show you a practice problem related to the force of friction. So I have a problem here where Dr. Longyear is moving a 50-kilogram box by pushing with 160 newtons of force. The coefficient of friction is zero point 0.3. What is the force of friction on the box and what is the net force acting on the box? All right, so I'm going to use a strategy that I like to use called GUESS, and I'll show you what that acronym means. I also want to draw a free body diagram to kind of help me understand what I'm dealing with here. All right, so first, let me write down some of the numbers that I was given and try to figure out what are my unknowns. So this acronym called GUESS, so G stands for given, U stands for unknown, E stands for equation, S stands for substitute, and the other S stands for solve. All right, so these are some steps that I like to follow anytime I'm given a problem. All right, so let's talk about the numbers that I was given. Well, I was given a mass that was 50 kilograms. I was given a force, an applied force, I'll call that like FA. My applied force was 160 newtons. I know my coefficient of friction is 0.3. And so that for that coefficient of friction, we use like a Greek symbol called mu, and I put a little k to specify that it is the kinetic friction. All right, what I don't know is I don't know the force of friction. That's what the question's asking for. And I don't know the net force. That's another question that I've been given here. So there's a few other things that the problem doesn't specify, but I can figure out, or maybe I can kind of assume. Because we're dealing with objects that are on Earth, like 99% of the time in the class, like 100% of the time in our life, the acceleration that I'll be dealing with is negative 9.8. And that's an important number to kind of keep in your back pocket. All right, I'm also going to draw the free body diagram for this. So that might look something like this, where I have a box. I know that I'm applying a force of 160 newtons. I know that there's some force of friction. I really don't know how big that is. That's what I'm trying to find. And I also know that there's going to be a normal force and a force of gravity. All right, so if I'm trying to find the force of friction, well, I know the equation for the force of friction is the normal force times the coefficient of friction. So we've looked at our givens, we've looked at our unknowns, and now we're starting to look at equations that we could use. Well, I know this is the equation, but I don't know the normal force. So one way to get around that is I can calculate the normal force. The normal force is equal and opposite to the force of gravity. So the first thing I'm going to have to do is I'm going to find the force of gravity. That's another equation that I want to use for this. The force of gravity is going to be my mass times the acceleration of gravity. Or in this case, I know those numbers. I can actually plug these numbers in. So this is where I can substitute and solve. I can find the force of gravity by doing 50 times negative 9.8. And doing that on the calculator really quickly is negative 490. So the force of gravity is negative 490. And one thing I know the normal force is equal and opposite to that. So my normal force is that same number, but just positive. So these are both measured in newtons. So force of gravity is negative 490. The normal force is positive 490. All right, so now I can come back to this original equation that I wrote down. Now I can actually solve this one because now I have those two numbers. All right, so I'm going to go force of friction is equal to my normal force of 490 times the coefficient of friction, which is 0.3. If I do that in the calculator, I get 147. So this is one of the numbers I wanted to have, right? This is one of the numbers I was missing. So I'm halfway done in terms of getting the answers I needed. I'm more than halfway done in terms of how much work I've done, because now I only have a little bit more work to do to find the net force. The net force is going to be the forces added together. Let me try to move this so I can get everything included here. So one thing I could do is I could try to figure out what is the net force in the y direction. I'm not going to bother with that because I know that these two are equal and opposite. I know I don't have any net force in the y direction. What I will have is a net force in the x direction from side to side. All right, and in that case, my net force is going to be 160 because that's the force I'm applying, minus the force of friction. The force of friction is going to be negative here because it's opposing my movement, right? It's going to be going to the left in this situation. So the net force overall is going to be these two numbers subtracted, and that leaves me with 13 newtons. And that's it. So I encourage you to use this strategy. I encourage you to write out the numbers that you have. I encourage you to write out the equations that you want to use. And this is the acronym I like to use to kind of solve any math problem I'm ever given. I also need you to draw a free body diagram because that kind of helps you think about the problem and get a good visual for what you're dealing with in the problem. And that's it. So I hope this was useful. Use this strategy when I give you friction problems. All right, good luck.